Good morning students. So here now I am making a video for calculation of SAG. We have already discussed about how to calculate SAG when the supports are at equal level and when the supports are at unequal level. So if both the poles are at equal level, then the SAG formula will be S is equal to W L square upon 8T, where W is the weight of the conductor per unit length, L is the span, that is distance between the two poles, T is the tension in the poles or in the conductor. So next is when the supports are at unequal level. So if we talk about hilly regions, then if the transmission line is installed in the hilly regions, then the supports or the poles will be at unequal level. So in order to calculate the sag when the poles are at equal level, the formula is S1 and S2, because there will be two sags, one from the pole at upper level and one from the pole at the lower level, right? So S1 is W x1 square upon 2T and S2 is W x2 square upon 2T, where again W is the weight of the conductor per unit length and T is the tension in the conductor. And x1 and x2 are given by these two formulas. x1 is L by 2 minus TH upon WL and x2 is L by 2 plus TH WL, where L is the span of the span conductors, that is distance between the two poles. Okay? T is the tension in the conductor and H is the difference in the height of the two poles which are at unequal level, right? So this is how these are the formulas which we are going to use in order to calculate the sag in the conductors when they are installed on the supports, right? So this is for equal level and this is for unequal level. So you need to remember these formulas for doing the calculations, as there may be 10 marks sums based on this sag calculation, right? So additional thing which we have to consider while calculating the sag is the effect of wind and ice loading. Now what do you mean by effect of wind and ice loading? So where there is ice or snowfall in such areas, what will happen is when there is snowfall, the ice will get deposited on the conductor surface, and this is going to add to the weight of the conductor, right? So now this, let us consider this as the cross section of the conductor, where D is the actual diameter of the conductor and the shaded region is the deposition of the deposition of the ice around the conductor, right? So let us consider that small d is the diameter of the actual conductor and T is the thickness of the layer of the ice which is deposited on the surface of the conductor. So